been a little bit since we talked about generators, but let's talk generators real quick. 22 says the smallest conductors permitted to be run, paralleled in 2 separate conduits between a 3-phase 250 kVA generator and a 480 volt distribution panel board are what gauge or KC mil. Okay, these are going to count on a couple things. One being Ohm's law. Okay, 2 is going to be the number of conduits that we have going to whatever the thing is, and 3 will be the rules of Article 445 for generators, and namely the ampacity of conductors. So let's start with the Ohm's law portion. I have a 250 kVA generator, so we can express that as 250,000 volt amps, right? Remember that? That all makes sense. That should be pretty straightforward. And then we are just going to ohms this law out, okay? I'm going to divide that by 480. And since I'm in 3-phase here, times 1.732. Okay, just a little Ohm's law, nothing crazy. 250,000, and I'm going to multiply that by open parentheses 480 times 1.732, close my parentheses off, and hit equals. Okay, it's a big number and I did it wrong. I hit multiply instead of divide. How could you let me do that? 250,000 divided by 480 times 1.732. That was about to get crazy and intense there for a second. 300.71 amps. 300.7 amps. Okay, so far so good, other than that math wasn't so good. So now we're going to check 445, and specifically inside of Article 445, we're going to be looking at the ampacity of conductors, because we do have a rule we need to apply by here. And 445.13a says the ampacity of conductors from the generator output terminals to the first distribution device containing overcurrent protection shall not be less than 115% of the nameplate current rating of the generator. Okay, so the nameplate current rating of the generator is what we just calculated. So we will just increase that by multiplying by 1.15. Okay, times 1.15. Okay, so we're going to beef that up a little bit. Times 1.15 equals 346 amps. 346 amps. That is the current we need a conductor for. But there's one more thing. We are paralleled in 2 separate conduits. Remember, when we have 2 separate conduits in parallel, that they will be sharing the load. Okay, they're going to work together to get this objective accomplished. So since they will be equally sharing the load, we're just going to divide by 2. Okay, each one will carry its own weight of amperes divided by 2. So I need conductors in each pipe that can manage 173 amps. Okay, 173 amps. So from there, I'm just going to cruise over to 310.16 and find my conductors. 173 amps. Looks like a 2-aught will get there at 175. Look, it is a holy grail table. Look at this. Look at all those shots we've been taking at it today. A lot of them. Okay, 173 amps. That is a 2-aught. Sound good to you? Remember that? Cool. Next. All right, 23. Let's do 23. 23, we're back to those transformers. These have been more recent, right? These were more recent. These should be somewhat fresh in our minds. 23 says the maximum size inverse time circuit breaker, or ITCB, permitted to protect the primary. Okay, we are talking the primary.